Hi, I'm Jeff Miller. I've been making chairs professionally for about 15 years now. But long before I started doing this for a living, I found myself in an apartment with no furniture, not much money, but the desire for some nice things. I found some plans for a table and chairs in a book of projects. The table was no trouble. In fact, some friends are still using it in their dining room. But the chairs were another story. They were uncomfortable to sit in, and they started to fall apart within a year or two, which was just as well because they weren't much to look at either. But I was too young to get discouraged and instead became even more intrigued with chairs. Now, after 15 years and countless chairs, I've finally puzzled out most of what it takes to make a successful chair. There are three big issues with chairs. There's comfort, structure, and appearance. And they're all connected in subtle ways. And I want to show you some of the things I've learned about them, so you don't need 15 years to work out all of the bugs. We've got an hour here, and so we'll only look at three of the most common chair types. But we'll cover most of the important technical issues involved in making them. We'll look at frame chairs, that is, chairs whose legs are held together by rails with mortise and tenon joints, or with dowel joints. Post and rung chairs, framed up from dowels or cylinders turned on a lathe. The joints are round tenons, fit into round mortises. And we'll look at chairs with plank seats and legs that attach with the aid of mechanical fasteners to the seat's perimeter. Frame chairs, joined by mortises and tenons, go back to the early Egyptians, and maybe even earlier in history. Structurally, we're talking about four legs joined together with rails below the seat and often stretchers lower down on the leg. This structure is the basis of all frame chairs. Here's a particularly simple chair that I use to demonstrate the basics of chair construction to my students. There's nothing here to strike fear in a woodworker's heart. It's all straight lines, right angles, and square posts. But still, there's some subtleties that are worth a closer look. The goal with mortise and tenon joints is to maximize the amount of good glue surface without weakening the parts that we're joining. Lengthening or widening the tenon is a good strategy for this, but when two seat rails meet at a leg post, their tenons will bump into each other while they're still pretty short, unless we move the rails and the joint to the outside of the leg. But you've got to watch the thickness of this little wall of wood between the mortise and the outside of the leg. This is too weak. In hardwoods, you need to leave at least 1/4 of an inch here, and in softwoods, at least 5/16. Same problem at the top of the front legs. You need enough wood between the mortise and the top of the leg to avoid splitting here when the tenon is driven in, or later when the chair is in use. I like a minimum of 1/2 an inch in hardwoods and 3/4 of an inch in softwoods. I begin my mortise and tenon joints by laying out the mortises. I set my marking gauge to scribe a line 1/4 of an inch from the edge. If I were going to chop out this joint with mortising chisels, I'd scribe both sides of the mortise, but I'll be routing, and the router bit takes care of the width for me. So I need to mark only one side. But I have to mark the locations of the ends carefully. When mortising with a plunge router, I like to use this simple jig I call a mortising block. It's just a 3-inch by 3-inch board, about 30 inches long, and it provides both stable support for the router as well as a straight edge to guide the router's fence. The clamps are standard bench hold downs. The track on the back side of the block makes it easier to keep the fence tight against the block. I set the depth of cut and start making sawdust. I'm eyeballing the ends of the cut, but I could easily add stops to control the router's travel. Route with lots of very shallow passes back and forth from end to end. If you plunge the router down too deep, you'll overwork the bit and actually flex it slightly, and it won't cut as accurately. When you're done, first carefully raise the router so the bit clears the mortise, then shut it down. Not bad. The mortise is crisp and almost exactly where I wanted it. I lay out my tenons directly from the mortises, although you could also locate them by careful measuring. I've set my rails in 1/16 of an inch from the edge of the leg. This looks good and spares you the effort of making these leg-to-rail connections flush. It would be a lot of work to fair them in perfectly, and less than perfect would just look badly done. I set the top to bottom location of the tenon in the same way, putting the rail exactly where I want it in relation to the leg and taking off the tenon's width. To finish the layout, I set my marking gauge a hair less than the depth of the mortise and scribe the shoulder line, which determines the tenon's length. Then it's on to cutting tenons. First, let me show you how I do this with a plunge router. My jig gets the router up square on the end of the rail. I've made a tenon template with a central strip that will guide the router. It's 1/8 of an inch narrower than the tenon I want. I'll clamp up the workpiece so that it just touches the underside of the template, and then adjust so that the maple strip is centered between my layout lines. Then I clamp the template in place. The router has a 1/2 inch bit and a 5/8 inch guide bushing installed, and the difference, 1/8 of an inch, is why my template guide strip is 1/8 of an inch narrower than the tenon that this setup will produce. I set the depth of cut to my scribed shoulder line. Make sure the router is fully raised up when you start it, then plunge down to full depth and start the cut. I take it slow with lots of light passes until I feel the guide bushing rubbing on that central strip in the template. Both the shoulder and the cheek are cut at the same time. If there's any router bit exposed below the guide bushing, wait for the router to come to a complete stop before moving over to cut the other side of the tenon. With this template approach, I can cut tenons all day without worrying about their thickness or location varying a bit. The depth stop ensures that the shoulders will always be aligned with each other. And the tenons come out looking clean. But there are lots of other ways to cut tenons too. My homemade table saw tenoning jig drops over the rip fence and holds the workpiece upright. To locate the tenon cheeks, you simply adjust the fence. I've got a flat-bottomed dado set on my saw. This will let me cut the cheeks and shoulders at the same time, as I did with the router. The accuracy of my tenon thickness depends on how well I set the two cheek cuts, so I generally sacrifice a test piece in order to get it just right. Now, I bandsaw away the waist for the top and bottom shoulders. Be careful not to cut deeper than the shoulder you've already established. A 32nd of an inch remaining waist is easy to chisel off. Use a chisel that's just a little wider than the tenon is thick, but not as wide as the rail. Now you could chisel the mortise square to match the tenon, but I find it quicker and easier to do it the other way around. I rasp the ends round. A few strokes is all it takes at each corner. And then I make sure the corners are clean, chiseling away any remaining waste from the shoulder and cheeks. Let's have a fitting. Not a bad start, but a little too tight. Here are some clues about the holdup. The rubbing has made the tight spots on the cheek shiny, and you can see that there's too much wood right there. So I just touch the shiny spots with my shoulder plane and then rasp away the tightness at the top of the tenon. Just make sure you know where the hang-up really is before you start to take away wood. That's better. A snug fit with just a little room left for glue. With the stresses that a typical chair sees over the years, even a good mortise and tenon joint can fail. That's why it's important to have a fallback. Well, maybe not the best choice of words considering the consequences of a failed joint. But that's what corner blocks are for. They brace and stiffen the frame and also distribute the racking forces more evenly on the rails. These blocks also make handy attachment points for the seat. It's easy to make corner blocks for a chair with right-angle joints. You set the table saw blade to 45 degrees and cross-cut the stock, flipping it over with each cut until you have as many blocks as you need. I set up my drill press with a bit designed for cutting pocket holes. It's got a replaceable center for the screw hole that slides into the counterbore part of the bit. My fence and stops help position the corner blocks for drilling. It's best to drill 2 holes on each side of the block. This adds rigidity to the chair. I install the blocks with drywall screws. There's no need to pre-drill the rails, but the screws go in much more easily when they're lubricated with a little soap or wax. All you have to do is sit down in a chair like this to realize why we don't often build them in just this way. People don't fit very well into right angles, and this chair gets awfully uncomfortable quite quickly. In fact, it's already quite uncomfortable. You can improve the comfort of a chair considerably by increasing the angle between the back and the seat by about 4 or 5 degrees. This is what I call my craftsman chair, after the craftsman style of furniture made popular at the beginning of the 20th century. The back angle doesn't make this chair more complicated to build. In fact, I still use right angle joinery throughout. The key to making the angled back is starting with a rectangular leg blank. I lay out the shape of the leg with a 1/4-inch plywood pattern. This block helps me align the lower part of the pattern precisely with the edge of the blank. I don't want to jog the pattern even slightly once I've set it up where I want it, so I'm careful to hold it snugly when tracing all the way around it. Then I mark out the mortise locations for the rails. I've got all this information right on my pattern, so I can set up and mark directly from it. Once again, I use pencil lines to mark the ends of the mortises and a scribe line to mark one edge. The squiggle reminds me not to cut on the wrong side of the line. Not that I ever make mistakes. On the side of the leg, I don't need the mortising block to help support the router. The leg blank is plenty wide. I just route with the fence, guided directly by the edge of the blank. Be sure to set the depth of cut carefully. But the front of the leg is too narrow a base for the router, so I use my mortising block. Once again, use lots of shallow passes back and forth between the ends. Once you've cut all the mortises for the rails and stretchers on the lower vertical part of the leg, it's time to saw it to shape. I try to bandsaw as close to the line as possible without going over. It's a big help if you use the wedge-shaped scrap from the front of the upper leg to help clamp the leg securely to the workbench for planing. The planing starts out pretty rough. There are a lot of little bandsaw bumps in the leg that you need to plane down before any real smoothing begins. But even in hard maple, the legs clean up pretty quickly. By skewing the plane, as I get into the area between the upper and the lower leg, I can plane a lot further into the curve. But my secret weapon is this compass plane. I can adjust the curve of the sole and plane right through the curve in the leg. A spoke shape would also work fine here. I'll show you a bit of that later. A scraper takes out the tiny ridges made by the skewed plane and makes the surface acceptably smooth. On the flip side, I draw in a defensive line that will remind me not to plane back too close to the mortise. Just above the mortise, I need some room for the tenon shoulder on the seat rail, so the pencil line is a warning to stay away from here. The entire lower face of the leg around the mortise needs to be perfectly flat and square for the adjoining tenon. It gets just a few smoothing passes, so there's little risk of angling the surface where the tenon will seat. Now I'll mark out for the mortises that will receive the back slats. Since their position is referenced from the angled back face of the rear post, I've had to wait until now to cut them. I transfer all the marks from my pattern again. I clamp the top angled face of the leg to the mortising block and have at it, again with lots of shallow passes. Be patient. A good mortise should last a long time. Once I've cut out the back leg for my craftsman chair, there's enough good wood left over for me to cut a front leg as well. But other leg shapes are not quite so obliging. With something like this, you'll wind up wasting a great deal of wood. You can solve that problem by nesting the leg shapes, which minimizes the waste. But your new problem is that you'll have to saw out the legs before cutting your joinery, and then find a way to square up and align the faces you'll be mortising. This leg is angled back both above and below the seat rail joint, so there isn't much surface remaining around the mortise to support a plane for flattening. This simple jig positions the leg and provides a surface to support and reference the plane. The back end of the plane rides on the block while the blade flattens and squares up the facet where the side rail will join the leg. Once you've planed a pair of legs, check to be sure those side rail flats line up. This is essential for a square back assembly. The lower legs are a bit off. That's okay. The uppers, where all of the joints will be, line up perfectly, as they have to. There's another way to trim the legs after bandsawing, by pattern routing them. This particular jig lets me flush trim both front and back of the leg by clamping the blank on the correct side of the jig. The big handles give me the big safety factor I need with that big bit. The pattern is guided by the pilot bearing just below the bit. You'll still have to sand or plane away the router marks, but you can save a lot of time this way if you're in a limited production run. You can easily jig up to route a mortise in a shaped leg, but here's how to chop out the mortises by hand. First, make it easy on yourself by drilling some of the wood out of the way, using a bit just slightly smaller than the mortise width. Drill to your finished depth. Now, chop away most of the waste, but don't chop all the way to the line. You can keep the final cuts absolutely straight and square with the help of a guide block, which I referenced from the front facet that I just planed. This sets the side of the mortise in just the right place, and it helps keep the chisel straight up and down when paring the mortise wall. Hold the chisel firmly against the block and try to pare away just a little bit at a time, moving along in overlapping cuts. For the other side of the mortise, I've made a block that references from the same face of the leg. This should mean that the two long sides of the mortise will be parallel, if I've made the jig well. I square up the ends as well, and this jig gives me a consistent mortise length from joint to joint. The frame chair started to take on some real sophistication in the early 17th century with the narrowing of the back of the seat, creating a trapezoid. The trapezoidal seat responds better to the way we sit in chairs than square seats do because we sit naturally with our legs spreading a little bit. And I think trapezoidal seats generally look better than square ones. Seats with parallel sides tend to look a little wider in the back than in the front. It's a quirk of perception and perspective, I guess. But the trapezoidal seat gets us into high anxiety woodworking, angled mortise and tenon joints. Well, to tell the truth, angled mortise and tenons are no big deal. First, we've got to determine just what angles we're talking about. I could take these off from my full-scale drawings for the chair, but direct measurements are more accurate, and I've got the dry clamped back and front assemblies to work with. I take the overall widths. I draw a center line perpendicular to the bottom edge of a piece of plywood, or a piece of paper. This doesn't have to be centered on the plywood, but it will be the center line of the plan view of the chair. On this line, I mark the perpendicular distance between the insides of the front and back legs. Here, it's 15 inches. Good nominal seat depths fall between 15 and 18 inches. I mark off the half width of the front assembly on a line perpendicular to the center line. And on the bottom edge of the plywood, I lay off the half width of the rear assembly. Connecting these points gives you the angle you need for the tenon on the rail. Now, I'll cut a wedge to this angle and use it to position the seat rails correctly in my tenoning jig. Then, cutting the angled tenons will be as easy as cutting square ones. Getting the overall length of the angled side rail is a little more complicated than the procedure for a square rail. First, I bevel the end of the rail with the blade set to the same angle I used for the wedge. I take the exact mortise depth on the front leg that connects with this rail. I rule off the tenon length, which is a smidge less than the mortise depth, with a ruler set perpendicular to the end bevel. And I draw in the angled shoulder line. To get the rail's shoulder to shoulder length, measure the drawing and lay off that distance along the edge of the rail. Mark the shoulder, measure the depth of the rear leg mortise, and mark this off perpendicular to the shoulder. Eyeballing these perpendiculars is quite accurate enough. Then, mark the tenon end and trim off with the same bevel angle as before. Now, place the rail in the precise relation to the leg that you want. Here, I've got my same 1/16 of an inch set in from the outside of the leg. Transfer the mortise width. Bring the two marks back to the shoulder line, parallel to the sides of the rail. This establishes the location of the tenon on the shoulder. Then, using a square set against the beveled end of the rail, bring the lines back up to the end at the correct tenon angle. I find that marking directly inspires more confidence than transferring measurements from a drawing. Fewer errors can creep in. I screw the wedge in the router jig, position the tenon template, and I hope you've got your goggles on. The router peels away the long-grain fibers like pencil shavings. They look nice and fluffy, but they're sharp as tacks if they get down your shirt. The wedge makes it easy to set up any tenon angle you want, but watch out for the short grain on the tenon. There's no exact answer to how much you can angle your tenon to the grain without weakening it too much, but you have to be alert to the possibility. Experience tells me that this tenon will be fine, however. On the table saw, the setup is just as easy, and the cutting goes just as it does with square tenons. All right, let's see what this chair looks like as a whole. I'll clamp up the frame tightly as soon as I've got the chair dry fit to be sure I've got everything just right. I pre-assemble the front and rear frames, as I will when I glue up, to keep the clamping manageable. With good, tight joints, there will always be some fussing to get everything together. On this chair, the back slats also have angled tenons. It's easy to take the angle right off the dry clamp chair. But I like to cut a test slat, partly to check the angle, but also to get an exact shoulder-to-shoulder measurement between the lower and upper rails. Just cut the slat short and then measure the amount you have to add to reach the top rail. Usually, I have to make a lot of tenons in a hurry because I'm trying to earn my living at this. Here's something that helps me: a special tenoning machine that uses a router to do the cutting. It's amazingly fast with these little tenons, and not bad even on the big ones. For these few slats, I've scribed a mark for the tenon shoulder rather than setting up a stop. The machine comes with a whole bunch of different tenon patterns, and you can easily make others. A stylus follows the pattern to trace the size and shape of the tenon. Corner blocks for trapezoidal seats are a little more work than those for square seats. There are two different angles to take, one for the front blocks and one for the rear ones. Here, I get the front angle by marking off an equal distance on both front and side rails. A straight edge goes across the marks, and I take the angle with the bevel gauge. On my slat-back chair, the cutting angle for the front blocks is 40 degrees, so I set up the table saw and go. The angle for the rear blocks is 90 degrees minus the front angle, or 50 degrees. Too steep to cut without the help of a jig, which holds the block up perpendicular to the table. And I don't even have to reset the blade because 50 degrees and 40 degrees add up to 90 degrees. I'm sure glad I paid attention in geometry class. Okay, not bad. Well, I guess you could say the next degree of comfort and complexity you could add to the frame chair would be a curved back. When you sit in a chair that relates well to the natural curvature of your spine, it's noticeably more comfortable because your muscles don't have to do all the work of maintaining good posture. Of course, you've also got to be free to squirm around a little bit. The joinery on a back like this is really no more difficult than on the bent leg of my Craftsman chair. The joints are cut into the rectangular leg blanks before the curve is sawn in. Or, if necessary, you cut the shape first and then square up the flats that take the side rails. How do you figure out what the curve should be? Well, first, there is no single perfect curve because we're all shaped just a little differently from each other. But all of our backs curve roughly like this. And a comfortable chair back should support the spine both here, around the level of the shoulder blades, and here, in the lumbar region. I like to experiment using a simple and inexpensive method, a plywood and dowel test chair. I bandsaw a very crude chair shape out of 2 pieces of medium-density fiberboard or plywood. Then, I stand one of these up where I can sit right next to it, at the most comfortable height for me. Normal dining chair seat heights are in the 17 to 18-inch range. I have my assistant trace the curve right off my back. You can also adapt, or out-and-out copy, a curve from some other chair that you like. The tracing tool is just a drilled dowel with a pencil stuck in one end. The rough curve is my starting point. Now I exercise some artistic freedom, smoothing out the lines till I've got something that looks promising. That little bump at the bottom came from a wrinkle in the waistband of my pants. Across the seat, I'll draw on a curve that I've used before successfully. On this line, I'll now space my dowel hole centers. Walking a pair of dividers up the line is quicker and more accurate than measuring and marking with a ruler. My spacing here is 1 inch. The marks aren't easy to see, so I circle each one and drill them out through the 2 plywood sides screwed together. This way, the holes will line up perfectly. I've set the depth stop so I don't drill through the lower side. I've got a big auxiliary table on the drill press to support the large MDF sheets. The dowels go into the side with the stop tools first. It's fun to see the contour take on a 3-dimensional shape. Putting on the other side isn't as hard as it might seem. The trick is to work on just one dowel at a time. Hold the side at an angle so you can do this, and be sure to keep tapping down the dowels you've already fit. Slowly make your way across the bottom, then up the chair back. This makes a surprisingly sturdy little chair. My weight is distributed over lots of dowels, so the chair is strong, and this one turned out to be really comfortable. But if it isn't, you can plug and re-drill some of the holes, experimenting with the areas that feel wrong to you. The saber leg will be the last joint frame we'll look at. It's an old, common chair type that evolved from a visual idea, not a structural one. It's still a simple frame chair with the 4 legs joined with mortises and tenons to the rails. The idea here is to flow the elements together into a curvy organic whole. The 2 side frames go together first, and these are attached together with the front and rear rails and the back slats. This type of chair was made popular in the early 1800s by Duncan Phyfe in New York. And the style named after him is still quite popular today. But the idea goes back to the klizmos chair in ancient Greece. You automatically get a trapezoidal seat by splaying the side frames. But now the angle tenons are on the front and rear rails. And there's a new technical problem to solve. Because these slats angle back inside the angled side frames, the top is shorter than the bottom, and the back is shorter than the front. This makes for compound angle tenons on these slats. But more about that later. All of the joinery for the side frames is done on the rectangular blanks. Then you dry clamp the frame and trace on the curves. If the chair is to be a prototype and you don't yet have a pattern, sketch and refine the curve right on the rough frame after first establishing some guidelines for the seat height and back slat positions. I left 2 mortises still to be cut for the back slats. These slats angle backward, and each one does so at its own angle. It's a comfort thing, and to find the best angles, I experimented with a mock-up. Then, I made up this mortising template so I could duplicate the results. The router's fitted with a 5/8 inch guide bushing that just fits the cutouts in my template. The bottom of the template is registered to the top of the side rail. When I go to cut the other side of the chair, I just flop the template over, and the resulting mortises will line up perfectly. When you're actually routing, the sawdust that remains in the mortise is a problem. It gets packed in between the guide bushing and the template, and you have to clear it out to be sure you're cutting the entire mortise. I guess you could bandsaw the entire chair side as a whole, but you'd need one heck of a big bandsaw, and it would still be awkward. So I saw out the parts separately, which is fine because they'll all be paired together, finally, when they're rejoined. I try to stay just outside the lines and cut smoothly and evenly. This takes concentration and practice, but little bumps aren't fatal. You'll just have to work harder later, smoothing them out with hand tools. Smooth the parts with anything you have available. Spoke shaves, scrapers, rasps, and hand planes may all come into play on different parts of a curve. The spoke shave smooths the bandsaw marks well, but with its short sole, it doesn't always even out the bigger bumps. If you skew the tool a little, you lengthen the sole with respect to the work, and it's easier to plane away irregularities. Pay attention to grain direction, or you'll see lots of tear out. With scrapers, grain direction isn't a problem, but scrapers follow the bumps without leveling them. Skewing the scraper helps to flatten the smaller ripples too. Use rasps on the tighter curves, cutting only on the push stroke and lifting on the return. Of course, you'll have to clean up the rasp marks. If nothing else works for you, try sandpaper backed up with curved sanding blocks. Start with 80 or 100 grit. It is a little slower, but it works just fine. And I'll have to finish this up with some 220 grit sandpaper afterwards. Now, back to that compound angle on the back slats. Clamp up the chair with the front and rear rails in place. Then measure for each slat's length by stretching 2 rulers between the tops of the mortises, but 1/8 of an inch in front of them, where the top front edge of the slat will be. Tenon up a test slat to this length, using the same wedge you used for the seat rails. Okay at the top, but that gap at the bottom is about a 1/48 of an inch. 1/48 over the 2 3/4 inch width of the slat equals a slope of about 1/8 of an inch over 16 inches. That's the slope of the secondary wedge I'll need to make the rail fit perfectly. I'll cut this out on the bandsaw. The primary wedge goes on the jig first. Then the secondary wedge goes on the side where it's held in place by the blank for the slat. It ain't magic, just good planning and measuring. Almost all frame chairs have what are called slip seats, an upholstered frame, or in this case an upholstered piece of plywood, that slips into a recess routed into the rails, or it can simply rest on top. I like to attach the slip seats too. I pound T-nuts into holes in the seat blanks and attach the seat with bolts that come up through holes in the corner blocks. I've never had time to do my own upholstery, and I'm kind of glad because just a few miles from here is a wonderful upholsterer named John Pfaffinger, who apprenticed at his trade 45 years ago in Germany. Hey, John.
Jeff, how you doing?
Good. How are you?
Okay.
Sorry.
Good to see you.
What are you working on here?
Finishing off this chair here with double weld, and then a cambric, and
Deliver it.
what do you got?
Well, I finally chose some fabric on this one here.
Oh.
And we want the usual look, something a little bit flatter.
Mm-hmm. 1 inch foam
Yeah, the 1 inch foam would be
and a
great.
half a layer cotton. How soon do you need it?
Well, they're pretty anxious for it.
I can start now.
Okay. That'd be terrific. I'll
Simple
see you a
thing.
little bit later.
All right.
Take it easy.
Of course, I only said that because Jeff got me into his video. Anyone else has to wait a week. For dining room chair seats, you should use 1 inch thickness of firm urethane foam. In the old days we used latex foam rubber, but it's much too expensive now and almost impossible to find. Trace the shape of the seat plank with a pencil and cut with scissors or a sharp knife. These are expensive fabric cutter shears, very comfortable if you are cutting all day. But the utility knife or even a kitchen knife will cut fine as long as it's razor sharp. Now I measure the width of the seat at front and back and make center marks on the underside. These will guide my centering of the fabric pattern later on. Next, tack or staple the foam at each corner of the board. Measure the seat left to right and front to back and add 3 inch to each dimension so you'll cut enough fabric to wrap around the edges. My work table is padded and covered in fabric because I occasionally have to pin things to it, but you can cut on any hard surface. Find the center of the fabric by folding in half and making 2 small cuts front and back. Before you cut though, you can adjust the fold slightly so the center falls correctly on the pattern geometry. This is 18-ounce upholstery cotton. I use only the highest grade long fiber cotton batting. Stay away from the cheaper grades that are made for mattresses. They contain oily bits of cotton seed shells and the oil will bleed into fabrics. I peel off the outer layer because Jeff wants to get a slightly flatter look. But if you were me, I go for a little something extra between my tuchus and the board. Tear off the excess cotton evenly. I leave enough to cover the edges for now. Then put on your fabric. If your fabric has a floral pattern, the flower should grow toward the back, which means flowers above stem when you look at the seat from the front. Match the center marks of fabric and plywood, and then stretching slightly, baste with upholstery tacks so that nothing shifts. In the old days, before the 1950s when staplers came out, this was the only way to upholster swiftly. I'm working with 3-ounce tacks, and the trick is to store them on one side of the mouth, toward the front, and then use the tongue to position them between the lips, heads outward. The magnetic hammer does the rest, with a little practice of course. I can't really recommend trying this if you're an amateur, but if you do, remember, have some sauerkraut in your shop just in case you swallow a tack. The sauerkraut will coat the tack to keep it from scratching anything as it goes through you. Continue to stretch the fabric from the center toward the corners. Look for a good balance of pattern. It's not hard to pull the tacks and adjust things at this point. Now I knock out the front basting tacks, tuck the excess padding into a roll at the edge of the foam, stretch a little more than before, and staple. The cotton batting must not cover the edge of the plywood. Otherwise, the seat would lose its sharpness. I use a pneumatic stapler, but there are strong spring-powered staplers that do the work just as well. The temporary tacks come out, one side at a time, and I continue to tuck, stretch, and staple, moving from the centers of each side to within 3 or 4 inches of the corners. I reinforce the corners with an extra wad of batting so I will get a tighter corner pleat. I shape the material into a nice round corner. Then I staple on one side of the corner, trim close to the staples so there will be no excess material. Then fold a tight pleat close to the corner so that it opens out to the side. The hammer helps flatten and even out the 3 layers of fabric in there. I staple it all together before going on to the other corners. The staple should be close enough together so there are no visible pulls in the fabric. If you've done all this, you can't be too far off, but still it's worth checking. You can always lift the staple to fix any pull marks. The final touch covers the exposed plywood on the bottom. This black gauzy material is called cambric and is not good for anything else but this. I just fold the hem so that it overlaps the edge of the cover fabric and staple it on. The whole seat should take about 20 to 25 minutes.
Back in my shop, I carefully cut little windows in the cambric, exposing the T-nuts. I used to think that drywall screws were okay as seat fasteners until my kids kicked their dining chair seats right off their screws. They'd have a heck of a time kicking this chair apart. There's one more thing to do before a chair is really finished. Glides aren't optional. They protect floors, and they also protect chair legs from damage when they're scooted across floors. The short grain at the bottom of a swept back leg is especially vulnerable. Glides come in metal and plastic, but I like these nail-on plastic ones because they're softer and less likely to scratch floors. Structurally speaking, post and rung chairs and basic joined frame chairs aren't so very different. But post and rungs are much easier to make. Their origins are humble. In early America, these chairs were often made by itinerant woodturners, also called bodgers, working with spring pole lathes and freshly cut wood. All you needed were some turned or even spoke-shaped pieces and a way to drill holes. Same thing today. All you really need is a drill press, some hand tools, and a can of hot sand. The sand helps to shrink the ends of the rungs for a tight fit in their mortises. Even with kiln-dried stock, this is a big help. Drilling good holes in round stock with a drill press involves just a little jigging. The main problem is holding cylindrical parts in place, and that's just what this jig does. The screw-down clamp block and the groove work together to lock the position of the dowel. I drill a 5/8 inch diameter hole in the test piece to find the center on the dowel. And I'm off a little. The dowel's just a bit too far from me. So I nudge the fence about a 32nd of an inch closer. Try again. And looks good, the mark's centered. Now I'll deepen the hole to show you how this thing really works. I insert a scrap rung, then rotate the dowel over until a side strip stops the rotation. This is to set up a 90-degree angle with the next hole. I reclamp and drill. And it really works. With just a little more ingenuity, we can have this jig drill sets of holes offset by any angle we want. Now, I mark up a real front leg post for drilling. My chair seat will be trapezoidal, not square. And I've designed it so that the front and side rung holes are angled 83 degrees to each other. These 7-degree hardwood wedges are all I need to make the difference. But the hinged top leaf of the jig can be set at practically any angle. I screw right through the wedge to lock everything into place. Now here, I've skipped over showing you one little step. I've readjusted the fence to center the hole in this new tilted configuration. First, drill all the holes for the side rungs. I put in a scrap rung and rotate uphill. Because of the wedges, this time the rotation is 90 degrees minus 7, or 83 degrees. Then I drill for the front rungs. All the drilling for the entire chair goes just like this, but with the back legs, I'll have to rotate the peg downhill, adding 7 degrees to get the necessary 97-degree angle. Now it's back to the mortising block, where the job is to route grooves for the chair's back slats. I've set up some grooved and hollowed grip blocks on the jig to hold the legs snugly. Make sure I'm square to the bit and plunge out the slots. I cut a groove near the top of the rear post to dress it up a little. You could also turn a finial. I always start assembly by checking the fit of the dowels. These sound like a bird call. Definitely too tight. I can't work them to the bottom. And the burnished tip at the end proves it. Okay, remember that hot sand? It's my incredible shrinking machine. The sand should get no hotter than 180 degrees. Somewhere between beef and lamb is well done. I unplug the hot plate and leave the dowels for around an hour. Test the fit again. You should be able to work the dowel right to the bottom of the mortise. I begin the assembly by getting organized, so I'll know what goes where once I'm in the thick of the glue up. Coat the entire surface of the mortise lightly with white or yellow glue. I like the new, slower setting glues because I hate worrying about the joints seizing up while I'm still fussing with them. Still, you've got to get a move on. Working the dowels by hand for the front and rear frames. Clamp briefly, tightening until there's no more movement at the joint. When you start to see the dowels flexing, you've gone too far. The side rungs have to be coaxed into their final position. The splayed mortises mean the rails will be too close together until they're completely home. But there's plenty of give in a chair like this. The clamps can come off as soon as the joints are snugged up. Start the seat weaving by marking and cutting a piece of 1-inch thick, firm urethane foam for the space between the top and bottom layers of webbing. The shakers use horsehair, but whatever filling you use, it helps distribute the sitter's weight from the top to bottom webbing layer. I'm using nylon webbing instead of the traditional cotton or wool tape. I like its texture and really bright colors. You have to sear the edges of the cut nylon so it doesn't unravel. I use upholstery tacks to attach the webbing to the chair. There's no sauerkraut in my shop, so I won't risk John's tack spitting technique. You could also use a heavy-duty stapler. I anchor the warp at the middle of a side rung. Warp is the weaver's term for the yarns or strands that are set up first on a loom before the weaving of the weft strands can begin. the chair frame is your loom. Wrap towards the front, then around and around until you've covered about half of the seat. Don't worry about tensioning yet, but keep the turns spaced quite closely, just about edge to edge. Then work the foam into place, loosening the webbing a bit if you have to. Keep wrapping the warp until you've completely covered the back rail. The tension is snug, but not taut. Then, tack the warp to the middle of the other side rail on the underside. Since the chair is wider at the front than the back, you'll have some gaps to fill at either side of the front rail. Tack filler pieces of warp to the underside of the side rails. Then bring them around to the top. Tack to the top of the rail. Begin the weft by tacking to the middle of the back rail on the underside. Start weaving towards the side rail over and under the alternate strands of warp, pulling the long tail of the weft strand through at each turn. To make this easier, I like to weave a loop of the webbing through and then pull out the remainder at the turns around the side rungs. There's no way to avoid this, but it gets shorter at each turn. Pull the webbing snug after each row, and after every few rows, work the weft tightly against the previous rows. Just keep on going, weaving on both the top and the bottom until you get close to the front seat rung. Now, it gets pretty tough to weave with just your fingers. You can use a blunt stick to push some doubled up webbing through, but I've made a sort of a curved needle out of wood. This is a shaker invention. Even with this, it's a push as you finish the last tight rows of weaving. Forceps are helpful in this operation, not just for grabbing, but for spreading the warp to tack the end of the weft. Didn't think it would hold me, did you? Actually, it's not a bad sit, but I wouldn't want to have dinner in a chair like this. Seriously, if you make a grown-up size version of this chair, there are a couple of comfort issues you'll need to deal with. The seat and the back are at 90 degrees. To ease this angle, the Shakers built many of their chairs tilted backwards slightly. You could also bend the back legs 5 or so degrees above the seat. And there's also the top of these two front legs sticking up past the seat, where the back of your thighs will be feeling them if you spread out a bit in the chair. Shaping the tops to a gentle curve helps a little, but the only real solution involves mortising the tops of the legs into a seat frame. Here's a very different sort of chair from all the others we've looked at so far. At first glance, you see a seat that's carved out of a glued-up plank, and that there are no seat rails. But the big difference is that the legs are notched into the edge of the seat and then screwed on. The notches resist rotation at the joints, but it's the screws that hold everything together. And the other big difference is that this has to be an armchair. In order for the notches to work, the front legs have to extend up past the seat. And the arms stiffen the entire frame by distributing the stresses from one joint to the next. When I glued up the seat plank, I was careful to place one of the joints right on the plank's center line. This joint will fall right in the middle of the little ridge that I'll carve into the front of the seat. I've planed the plank smooth and cut it to size, and now I mark out the locations for the notch joints and bandsaw the rear notches. You could cut these by hand as well. My pattern helps me to set up the stops for the front notches, which are easily cut on the table saw because they're square. I clamp these to the high backer board that's screwed to my miter guide. Out goes the pattern, in goes the seat plank. A dado blade helps get the wood out of there quickly, and it leaves an acceptably smooth surface on the bottom of the notch. If you use a regular blade, you'll need to chisel out any roughness on the bottom. That's an important glue surface. With all of the plank notches cut, I move on to the legs. I've marked both the front and back legs with my patterns. For now, I'm bandsawing only the outsides of the legs, the sides that won't be notched. I measure the thickness of the seat plank carefully at each of the joints. Then mark out each corresponding leg notch with this dimension. It may seem silly to take measurements with calipers when I mark with a pencil and cut, finally, by eye. And indeed, marking with a knife is clearly more precise. But I've gotten used to doing it this way, and I'm very careful to try to split the pencil line with the cut. It works for me. Or it did this time. Anyhow, I've got a nice tight fit, but not the final fit. There are a few more steps left to complete this particular joint. Using this template, I route shallow recesses in the sides of each front leg. This will put more shoulders to work in the joint, making it more resistant to movement. Also, this design deepens the engagement of the leg with the seat without taking away enough wood to weaken the leg. Experience has taught me to chamfer away the outside corners on the seat blank. This helps prevent splitting off wood when pulling the leg out of the notch after a test fit. The joint should be tight. It should take a little work to get it together. The final step is to round over the edges of the seat blank. I'm using a 1/4 inch radius roundover bit, which matches the 1/2 inch diameter bit I used to cut the side recesses. I do this only in the vicinity of the notch. Be careful not to round over the inside of the notch itself. All right, there's a front joint. The back legs are easier on this chair. I've notched both the front and inside face of the leg. The 2 notches add up to a very stable joint. When the joinery is done, we can get on with finishing the shaping. On the legs, this means bandsawing a curve into the notched side and then smoothing. The seat is a little more work. First, mark out and cut the seat's profile, hanging onto the cutoffs which will help in clamping the curved profile to the workbench. Secure the seat to a solid work surface, then mark out the boundary between the flat periphery of the seat and the central scooped out area. I try for a pleasing symmetrical curve that comes inside the notches by about 1 inch. I start the rough carving with a small Japanese scrub plane, which has got a curved sole and iron that I've set to get rid of a lot of wood in a hurry. And get rid of wood you must. The seat has to be deepened to at least 3/4 inch at the back. Two hollowed ramps for the legs will slope up toward the front, where they'll be separated by a well-defined ridge. 3 inches or so from the front edge, the hollows ramp back down again toward the front. Flipping the seat around on the bench makes it easier to work both the steep slope at the back of the seat and the fronts of the leg hollows. Mostly, I'm planing at an angle to the grain. When I go parallel, I have to pay attention to the grain direction. Planing downhill to a lower part of the seat usually helps avoid tear-outs. I'm mostly relying on my eye for a symmetrically sculpted seat, but it really helps to work for a few moments on one side, then switch to the other side and develop the same shape. Make sure to deepen the fronts of the leg hollows. I carve mine at least 1/2 inch deep. This is comfortable on the backs of the thighs. When I'm satisfied with the roughing, I move on to an in-shave, also called a scorp. This tool has a much bigger radius and cuts down the ridges left by the plane. You've got to experiment a little to find the right angle for the in-shave cut. Use a firm grip and a steady pull. I'm still cutting at an angle to the grain most of the time. And I use the sharper radius out towards the handles to smooth the tighter curves on the seat. Use your eyes and hands to check your progress. You can feel irregularities that you just can't see. And be sure to actually sit on the seat to see how it feels where it counts. This one needs to be a little deeper at the very front, and the central ridge is too high towards the back. This ridge almost always needs to be cut down a little. A small, smooth plane is fine for this. Pay particular attention to the center ridge. Work both sides of it carefully to keep the ridge line straight. But don't worry about perfection. You'll refine the ridge with sandpaper later. A final check, and it's time for some sanding. I start with 40 grit sandpaper in a random orbit sander, and this does a good job at cutting down high spots. Work the border area carefully with the sander tipped up a little so it sands the curved surface without rounding over the flat border. I keep going until the surface is evenly sanded, then brush off the dust and sanding grit and switch to a scraper. This may seem like an odd choice, but we're still trying to make all of the curves fair and smooth, and it's very hard to see the little irregularities before the finish goes on. Scraping the whole surface lightly will instantly highlight any low spots. The toughest areas to even out are the very back of the hollowed seat, the sides of the center ridge, and the very front of the seat. For each of these areas, I pick a curved sanding block to roughly match the curve I'm dealing with. I'm still not as concerned about cross-grain scratches as I am about even curves. I like making chairs because it allows me to connect with people in a way that's more direct than with almost anything else I can make for them. My clients, family, and friends sit in these things and respond to them, and they let me know how I'm doing as a designer and craftsman. And that, as much as anything, has allowed me to grow in my work. Luckily, you don't have to go far out of your way to study chairs. They're everywhere and almost infinite in variety. At home, in offices, restaurants, museums, you'll get lots of ideas about shape, structure, and feel. To translate these into your own chairs, you may need to learn more about measuring furniture and other skills like carving and turning. You'll find plenty of help in workshops, books, and videos to get you started. Meanwhile, don't be afraid to jump right now into projects that are within your grasp. Good luck.